Hello guys, welcome back to lecture series on statistics. In my today's video guys, I'm gonna explain to you all the coefficient of variation, which is very much important guys. Mark my word, you will get one question definitely based on the coefficient of variation. Okay, so for that coefficient of variation, I'm gonna explain to you all one or two result, and using this one I'll explain to you all one of the example that we have one comparison between this player. Okay, so we go for the example later on. First of all, let me explain coefficient of variation. Okay, what actually the meaning of coefficient of variation. For that particular coefficient of variation, we just need to know one formula. Okay, so guys, if you like this such my videos, let me know in my comment section guys. Okay, and for similar videos, go and check in I button or in my description box. You will get the complete entire playlist. Okay, let's get dive into our today's lecture. I'm gonna explain to you all first of all the coefficient of variation using the formula. Okay, so actually these two remarks you need to remember here. Okay, so coefficient of variation means standard deviation by arithmetic mean. Okay, standard deviation by arithmetic mean for that particular data. Okay, standard deviation by arithmetic mean for that particular data multiplied by 100. Okay, you will get the coefficient variation for that particular data. Okay, and one more remark, when lesser coefficient of variation, that means whenever we have first data gives us the lesser value compared than another data, so we consider first data as a more consistent. That means lesser coefficient of variation is a more consistent value. Okay, so using these two remarks, we're gonna go and solve one of the example guys. One of the question definitely you will get in your SPPU question paper. Maybe not that question, you will get some another question, but similar example definitely you will get. Okay, so maybe there are values are replaced or there are some another example, but need to understand we how to apply these two results only. Okay, with only two results you can solve this example. Okay, such examples are coming for 5 marks. Okay, so make sure that take it note and listen it carefully. Okay, yes, so here I written one example here. I'm gonna solve this example using coefficient of variation. Okay, so what the example says that the following are the runs scored by two batsman capital A and batsman capital B in a 10 innings. Okay, that they played 10 innings. Okay, so within the 10 innings, batsman A and batsman B did this score. Okay, so for this particular first inning, batsman A did 101, did that score 101, and batsman B 97. For the second inning, batsman A 27, batsman B 12. Third inning here, fourth inning here, fifth, sixth, seventh, eighth, ninth, 10. Okay, these are the total 10 innings given here. Okay, and we have to figure it out who is a more consistent player. Okay, more consistent means more effective player. Which one is the more effective player? Okay, now see that this one is the player A, this one is the player B. Okay, so for finding their coefficient of variation. Okay, first of all we have to find out the coefficient variation for A, coefficient of variation for B. Okay, so we go for finding the coefficient of variation A and coefficient of variation B. Okay, and we compare their coefficient of variation, and whatever the less value it gives, okay, it is a more consistent. Okay, so let's go for finding the coefficient of variation for A and coefficient of variation for B. Okay, yes, so let's consider A as a X. Okay, because see that we are not going to take A as it is, because we consider before that some another variable for the standard deviation in order to avoid a misunderstanding about the variable. I consider here X as a A. Okay, this is just a consideration guys, don't get confused. This is X and this is a Y. Okay, this one is the value for entire X, this one is the entire value for B. Okay, Y I consider here. Okay, so using this one we go for finding the coefficient of variation. Okay, and coefficient of variation, what it says that guys, standard deviation upon arithmetic mean. Okay, standard deviation upon arithmetic mean into 100. Now standard deviation, it is way easier. I already explained how to find out the standard deviation. We go for finding standard deviation by short calculation method. Okay, we apply short calculation method like a u which is equal to x minus a. Okay, that one we apply. Okay, and then later on we go for the comparing them. Okay, arithmetic mean, we also go for finding the arithmetic mean. Now see that we have two type of the data set. Okay, for batsman A this one, and for batsman B. So we consider one data set separately. I'm gonna consider that A data set first of all. Okay, and I'm going to write all their values. Okay, yes. So now see that guys, it's not that difficult. Let me write the horizontal table into the vertical form. Okay, so we are going to find out the value for A separately, for batsman A separately, and for batsman B separately. Okay, these are the two different table guys, don't take it together. Okay, yes. So I'm going to consider here first X here. Okay, what is the value for X? That means Xi. Okay, 101, 27, 0, after that 36. Okay, write down all these values over here guys. Okay, I'm going to copy this value here. 0, 36, 82, 45, 82, 45, 0, 36, 82, 45, 7, 13. Okay, 7, 13, 65, 14, 65, 14. Okay, these are the all xi we have given guys. Okay, so I'm doing it for only the batsman A. Okay, for batsman A I want the standard deviation, sigma, arithmetic mean, and coefficient of variation for batsman A. Okay, yes. So for finding the standard deviation guys, we go for u which is equal to x minus a formula. Okay, what the formula we have? U which is equal to x minus a. Then standard deviation we write guys, sigma x or sigma u as a summation u square, as we have this data in the form of ungrouped data. Okay, that means simple form of data, so you don't have to consider the result for the group data. Okay, so we apply ungrouped data, so simple form of data result we apply over here. Okay, yes. So first of all we go for finding u. Okay, so what is the u here? U is equal to x minus a. We know that u is equal to x minus a, so we have to find out the value for a. So what is the value for a? That we have to decide it using this table. Okay, yes. So find out the middlemost value from this table. Okay, so let me write the value over here. So see that guys, I'm going to apply shortcut method here for finding the calculations. So I converted this table into the vertical format. Okay, horizontal table to the vertical. Now see that I'm going to apply shortcut, means u is equal to x minus x bar. Okay, that one is I'm going to consider as the value for u. Okay, yes. And we know that for finding the standard deviations, okay, sigma x, we consider whether it is the sigma x or sigma of u. Okay, this is the standard formula guys. Okay, yes. So we write it is the under square root, I already explained guys these formulas. Okay, under square root sigma of u square, okay, divided by down, see that divided by we have n. Okay, see that guys, we have formula summation of u square divided by n. Okay, n means number of players, that means number of observation. Summation of u square divided by n means number of observation minus, okay, minus what we write next value here, summation of u, okay, entire summation of u bracket complete divided by n bracket square. Okay, this one is our required formula. Okay, that formula we use for finding the sigma x or sigma u. Okay, this one is easy guys. Okay, just need to remember this formula, sigma x sigma u, for this one particular batsman A. Okay, similarly I'm going to apply this formula for batsman B also. Okay, yes, it is way easier guys, not that difficult. Okay, yes, you can easily understand this formula. Okay, now see that in our formula I written over here, okay, sigma x as, or sigma u as summation of u square divided by n minus summation of u bracket square by n. Okay, so for that formula we need a u. U means x minus x bar. Okay, and x bar means arithmetic mean. Arithmetic mean means we have to add all of these xy divided by n. Okay, so after you are going to find x bar, you will get the x bar as a 39. I'm not taking your time guys, you can find that arithmetic mean x bar, you will get the 39 here. Okay, x bar as a 39. So add this number divided by your 10. Okay, so you will get the 39. Okay, that means you have to take the average for all these number, guys. Okay, so you can do it very easily. Okay, let me write the next table here. U as a x minus x bar. Okay, x minus x bar as a u. Okay, then let me find the all values. Then we go for finding u square, that we can replace here. And we know that n it is already 10 players, means 10 matches. Okay, 10 innings means n is a 10. Okay, so you can replace n is a 10. Let's find out the u and u square. Okay, let me write the all values here. So see guys, here I found the value for x minus x bar, x minus 39, entire table over here. U square means find out the value for find out the square for this entire term. So 62 square means 3844, minus 12 square means it is 144, because it is a even square, so negative sign it will get absorbed. Okay, minus 39 square 1529, 3 square 943 square 1849, until till that minus 25 square it is a 625. So as we know, we needed here summation of u. Find out the all sum for this number, you will get it 0. Okay, yes, after that we needed summation of u square, so find out entire sum for u square, you will get the 10,404. Okay, yes, summation of u square over here. I got the summation of u square. Put all this value, you will get the sigma x, or we consider it as the sigma of u. So see guys, I replace the values here. Okay, summation of u square, it is a 10,404. Okay, the 10,404. n is a 10 here, minus summation of u, it is a 0 upon 10 here, bracket square, 0 upon something, it goes to 0. If you're going to divide this one and going to take the square root using calc, you will get the value for sigma x and sigma u as a 32.26 here. Okay, so this one is the value for sigma x and sigma u. Okay, now we have to find out the coefficient of variation. Okay, what we needed here, we left here with the value of our coefficient of variation for what we needed, coefficient of variation for x. Okay, that means this is a sigma x. Okay, coefficient for variation for x, we write as sigma x upon x bar. X bar is arithmetic mean. Okay, multiplied by 100. Put the value for sigma of x, it is a 32.26. Okay, total divided by x bar, what we have here, 39 multiplied by 100. Okay, yes, so if you are going to find out the value, okay, if you are going to find out the value, you will get the coefficient of variation. Okay, let me write that coefficient of variation for x. Okay, coefficient of variation for x, it is the 82.72 percentage. Okay, this one is our coefficient of variation for x, guys. Okay, this one is the coefficient of variation for x here. Okay, so I did it for the x, guys, here. Okay, similarly this entire process, this one is the entire process, guys, you have to repeat for the y that I consider for the batsman B. So I received the coefficient of variation for x. Similarly we have to follow for the coefficient of variation for batsman B. So for that B, we have to apply similar table again here. Okay, so as a process it is completely similar, guys, so that's why I'm skipping the table. Okay, so I'm going to take directly the values. For your better understanding, I suggest you all to go for the separate table. Draw the table, find out the value, and you will get the required answer. Okay, yes, let me take the calculation directly. Keep that table for your homework. So guys, see that as we have all calculations similar, so that I'm taking some shortcut here, because if I'm going to explain that method here, so it will be little lengthy video. Okay, so if you all have understood my previous part of the solution now, so this one is a way easier, guys. As we have found x bar, similarly find out the y bar, means arithmetic mean. So that table, first of all take it into the vertical form. Okay, write down the value for y that we consider for the batsman B. Okay, find out their y bar you will get it 43. Okay, so instead of u, now I'm going to consider it is the v which is equal to y minus 43. Okay, find out the v, take their sum, okay, and the summation of v, write it here. Okay, again take the v square, you can take you will get the v square, entire x, take the square for all these terms, you will get the v square. Okay, find out the summation of v square at the end. put these values over here. Okay, put all these values over here. At the end you will get the value for this summation of y. Okay, sigma of y as a 35.72. Okay, this one is the value for summation sigma of y, guys. Okay, so but we want the coefficient of variation for y. Okay, so how can we write the coefficient of variation for y? Let me write coefficient of variation for y. Okay, coefficient of variation for y, we write summation sigma of y divided by, okay, sigma of y divided by arithmetic mean of y, which is y bar, multiplied by 100. Okay, so put the value for sigma of y. Okay, the sigma of y we found here. Okay, what is the sigma of y we have here? 35.72. Okay, divided by y bar. Okay, y bar it is 43 multiplied by 100. Okay, yes, so if you're going to take the calculations, you will get the 83.07. okay, 83.07 percentage. Okay, so you can take that 100 as a percentage. Okay, so it is a way easier, guys. Okay, yes, so see that, guys, we got the value for coefficient of variation for y, which is equal to 83.07. Okay, calculations are quite easier and similar like my previous part, so that's why I skipped this calculation. You can do it by yourself. But even after, guys, if you found it confusing now, keep this example for me. I'll explain in my next lecture. Just let me know in my comment section. Okay, so I got the coefficient of variation for y, and as well I got the coefficient of variation for x also. Okay, now so compare this. Okay, coefficient of variation of x. Okay, that is for the batsman A. Okay, and coefficient of variation of y, that is for batsman B. Okay, that is for batsman B. So coefficient of variation for x, that is for A, which is the 82.72. okay, which is the 82.72 percentage. Okay, and the for y we have 83.07 percentage. Okay, now see that 83 means it is a bigger value. That means it represents that coefficient of variation for x. Okay, that means coefficient of variation for batsman A is smaller or lesser than coefficient of variation for batsman B. Okay, and the more lesser value, that is the consistent solution or precise solution. Okay, so that means batsman A is more consistent than batsman B. The lesser value is a more consistent. Okay, that is, let me write, the batsman A is more consistent, than batsman B. Okay, batsman A is more consistent than batsman B over here. Okay, so that's it we want here in our example, guys. Similar type of the example definitely you will get it in your question paper. Okay, these are not difficult example, guys, but these are the little time taking, but they are easy. So if you prepare it properly, guys, you will get the complete solution. Okay, now for your reference you can take that sigma y. Okay, y that phi and phi square, find it out, guys. Okay, replace the value, you will get the complete solution. Okay, that one is our required solution. Here you all need to remember coefficient of variation formula, which is a sigma divided by arithmetic mean into 100. Okay, that formula you all need to know. And again, the value which is lesser than, that means it is a more consistent. Okay, yes, that is here for my today's lecture. I hope you all guys understood my today's lecture. It is quite easier, but if you take it properly, if you understand concept wise, you will get all this concept perfectly prepared. Okay, so I hope you all have understood everything here in my today's lecture, guys. For similar videos, do check in my description box or here in I button. Okay, so thank you everyone, thank you for my today's lecture.